When we hear the word vision, we most often think about eyesight, or our ability to perceive shapes and objects and faces and colors. And indeed, vision involves eyesight, our ability to see shapes and objects and faces and colors and so forth. However, our eyes are responsible for much more than that, including our mood, our level of alertness, and all of that is included in what we call vision. So I just want to take about 3, maybe 4 minutes and talk about how the visual system works, how it's built, and how you are able to so-called see things around you. I also want to describe the ways in which your eyes and your visual system impact your mood and your level of alertness. And then we are going to get right into some protocols, some specific things that each and all of you should do if you want to enhance your vision and maintain your vision as you get older. And again, if you're a 15-year-old or a 12-year-old, this episode is especially for you because your nervous system is far more plastic than mine is. It's much more amenable to change, so you can really build a very strong visual system. And in doing that, and if you adopt specific behaviors at any age of light viewing at particular times and particular ways, then you can build an emotional system that's also reinforced by your visual system. So let's talk about vision. What is vision? Well, vision starts with the eyes. We have no what's called extraocular light perception. While it feels good to have light on our skin, while it feels good to be outside in the sunlight for most people, the only way that light information can get to the cells of your body is through these 2 little goodies on the front of your face. And for those of you listening, I'm just pointing to my eyes. As many of you have heard me say before on this and other podcasts, your eyes, in particular your neural retinas, are part of your central nervous system. They are part of your brain. They're the only part of your brain that sits outside the cranial vault. In other words, you have 2 pieces of your brain that deliberately got squeezed out of the skull during development and placed in these things we call eye sockets. There's a genetic program for the specific purpose of making sure that 3 little layers of neurons, nerve cells, got squeezed out and form what are called your neural retinas. Now, the eyes have a lot of other goodies in them that are very important, and those are the goodies that we're going to focus on a lot today. There's a lens to focus light precisely to the retina. If you're somebody who requires eyeglasses or contacts, chances are you don't do that correctly. And so that's why you use other lenses like eyeglasses or contacts. There are also other pieces of the eye that are designed to keep the eye lubricated. You also have these things that we call eyelashes. Most people don't know this, but eyelashes are there to trigger the blink reflex if a piece of dust or something gets in front of your eye. It's a beautiful adaptation of nature. They aren't just aesthetically nice. Costello happens to have very long eyelashes. He gets compliments about this all the time. Maybe you have long eyelashes. I don't have particularly long eyelashes, but the eyelashes are there so that if a piece of dust or something starts to head towards the cornea, the eye blinks very, very fast. It's the fastest reflex you own, is your eye blink reflex. We also have these things called eyelids. Now, eyelids might seem like the most boring topic of all, but they are incredibly fascinating. Today, we're going to talk about how you can actually use your visual system to increase your levels of alertness based on the neural circuits that link your brainstem with your eyelids. And no, we are not going to have a blinking contest because I would win and you would lose, and that wouldn't be fun for you. So, let's talk about what the eyes do for vision. Basically, the entire job of the eyes is to collect light information and send it off to the rest of the brain in a form that the brain can understand. Remember, no light actually gets in past those neural retinas. It gets to the neural retina, and we have specific cells in the eye called photoreceptors. They come in 2 different types, rods and cones. Cones are mainly responsible for daytime vision, and the rods are mainly responsible for vision at night or under low light conditions, generally speaking. So basically what happens is if your eyelids are open, light comes into the eye, the lens focuses that light is also just called photons, light energy, onto the retina. These photoreceptors, the rods and cones, have chemical reactions inside them that involve things like vitamin A, and that chemical reaction converts the light into electricity. Now, that might seem incredibly abstract, but the way to think about this is very similar to, for instance, you have touch receptors on your skin, and when you press on those touch receptors, they convert pressure, physical pressure, into electrical information, and those neurons send it up to your spinal cord and brain. You can register that somebody or you are touching the top of your hand, as I'm doing now. With the eyes and the retina, it's just that light gets converted into electrical information. Within the eye, within the retina, there are then a series of stages of processing, and that information eventually gets sent into the brain by a very specific class of neurons. I would like you to know the names of these neurons. They're called retinal ganglion cells. So the only thing you need to know about the neuroscience of the eye at this point are that they're rods and cones. The cones are involved in bright daytime vision, and rods are involved in more dusk or nighttime vision. And you've got these cells called retinal ganglion cells that send the information off to the rest of the brain. Now, here's what's incredible. I just want you to ponder this for a second. This still blows my mind. Everything you see around you, you're not actually seeing those objects directly. What you're doing is you're making a best guess about what's there based on the pattern of electricity that arrives in your brain. Now, that might just seem totally wild and hard to wrap your head around, but think about it this way, because this is the way it actually works. Let's take an example of a color, like green or blue. You have cones in your eye that respond best to the wavelength of light that is reflected off, say, a green apple. So you don't actually see the green apple. What you see is the light bouncing off that green apple and goes into your eye, and you see it and perceive it as round and green, but not because you see anything green. No green light arrives in your brain. What happens is your brain actually compares the amount of green reflection coming off that apple to the amount of red and blue around it. Well, you might say, well, the green apple is sitting on a brown table or a white surface. Well, then it will appear very green because the amount of wavelength of light for green is very high and the amount for red is very low, and so it looks very green. Okay? So we don't actually see anything directly. What the brain is receiving is a series of signals, electrical signals, and it's comparing electrical signals in order to come up with what we call these perceptions, like I see something green, a green apple, or I see red. Let me give you a slightly different example. If you were to play a key on the piano, let's say you play, I'm not a musician, but hopefully I won't get this too incorrectly, but let's say you have like E sharp, and maybe it's on ding, 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 ding. If the brain gets that signal, it doesn't actually know E. It doesn't recognize it until you were to play another key next to it, dun, 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 dun. And what it does is it does the math, it does the subtraction, and it compares those two. So when we see something green, or we see something red, or we see something blue, we're not actually seeing it directly. The brain is making a guess about how green or red or blue that thing is by comparing what's around it. Okay? And if that seems hard to wrap your head around, don't worry, because we will explain it in more depth going forward. But I really want people to understand this, that vision, eyesight, is not looking at things directly and that information getting directly into your brain. It is translated. Light information is transformed into electrical signals that your visual system exquisitely understands. Now, what does this mean? Why should you care about this? Well,